Today we are looking at topic 2 in environmental chemistry. This is called a growing concern. Okay, so controlling other species. Why do we control other species and how are we doing it? So humans, we control other species for farming and agriculture, right? We want to maximize the quantity of plants that are harvested. So pesticides are being used. These are the general category of pesticides, which is a chemical used to control pests. So more specifically, there are herbicides. These are chemicals used to control weeds. There are insecticides, which are chemicals used to control insects. And then there are fungicides, which are chemicals used to control molds and fungi. Just to specify here, chemicals, for example, like DDT, which are sprayed on crops and crops usually and during farming, they actually are killing the insect. Okay, they're not just sending it away like some citronella candles or mosquito coils do. These chemicals, they actually kill the insects. Same with if it was a weed or a fungi. So DDT, diphenyl trichloroethane, was invented by a Swiss chemist, Paul Hermann Müller. It was originally considered one of the greatest advances in medicine during the 20th century. Reason being, a lot of diseases were being carried by certain insects. For example, towards the end of World War II, the typhus disease threatened 1.3 million Allied troops, and this disease is transmitted by lice. So the application of DDT completely removed that typhus threat. But as we saw later, there were harsh consequences to the environment and other species. So DDT, it did prove to be successful in controlling insect infestations, and that scientist, Paul Müller, was awarded the 1948 Nobel Prize. Okay, here we're just looking at this tidbit that it's called Operation Cat Drop. So what happened was in 1955, the World Health Organization, WHO, they sprayed a chemical called dieldrin. It's a chemical pesticide that is similar to DDT. And they sprayed it on North Borneo to control malarial mosquitoes, so mosquitoes that carry malaria. And so it worked really well. The mosquitoes were almost completely eliminated, but so were the lizards that fed on the dead insects. And then island cats that preyed on the lizards, they soon began dying as well. And this led to an explosion of the rodent population, all right, like rats. And reason being was because their natural predator, the cats, they died off. So the disease, the plague, is carried by fleas on the rodents. So it became a serious threat to the people living there. So then the British Air Force, on request by the WHO, parachuted cats onto Borneo. And that's what's happening here. You got cats here being parachuted, and they're landing here on land. All right, so next we're talking about biomagnification. So the process whereby chemicals accumulate in the tissues of organisms along the food chain. All right, so here in this example, we're looking at DDT in a North Pacific Ocean food web, and it's in ppb, which is parts per billion. So you'll see everywhere here ppb, and that stands for parts per billion. So the arrows are showing the flow of energy always towards the species that is feeding or eating that other species. So here we see the seabirds, which feed on the fish. They're at a higher feeding level, and they contain a much higher concentration of the DDT. We can also see that dolphins also have a much higher concentration of the DDT as well. All right, compared to plankton, which is at 1.7 ppb, and looking at dolphins, it's about 5,200. Seabirds are 2,800. All right, so it really does magnify as you go up the food chain. All right, so that was just a quick video there showing biomagnification and how toxins can travel up the food chain. So next, we're just looking at pesticide resistance. So what we can see here in this graph is how, well, the title is pesticide resistance. On our x-axis here, we can see the year, and then on our y-axis here, we see the number of resistant species. All right, so in like the pink, we can see insects and mites. In the blue, we see plant diseases, and in the green, we see the weeds. And what we see here is the growth, just the growth in the number of resistant species. So let's see here. So the ban on DDT, it did have serious health effects for humans living in areas with malaria. In Zanzibar, the incidence of malaria dropped from 70% in 1958 to 5% in 1964 because of the application of DDT. But then, as scientists realized the consequences of DDT and they started restricting the use of DDT, the incidence of malaria, it reached 50 to 60% by 1984. So another thing to note is that these attempts to produce safe and effective pesticides, it has also led to pesticide resistance. So basically, species are able to survive in the presence of those chemicals. Those chemicals are not harming them anymore. And it can produce, for example, superbacteria that can survive and can survive antibiotics. So therefore, you have these species now with antibiotic resistance.